All right, so in the last video, we were looking at finding powers um, of a complex number that was written in polar form. And now I'm flipping that around and I want to find the roots. And here I want cube roots, all the cube roots of this number, and it's a complex number written in polar form. So we're going to kind of do something similar we did when we were finding powers. Do you remember how if we're trying to raise something to say the fourth power, we would raise the modulus to the fourth power, but then we would multiply the angle by 4? Well, roots is kind of the opposite of that. So since we're looking for a cube root, we're going to do the cube root of 125 and then basically divide the angle by 3. But you've got to have this extra little piece that makes this one a little bit harder to think about. You are going to do the cube root of the 125, and you are basically going to divide that angle by 3, but you want to think about the 210, and then you want to think about adding a multiple of a complete rotation. And since we're in degrees, we'll think of it as 360 n. If we were dealing with radians, that's when you would add like 2n pi to everything. So you're going to add that to it and then divide by 3. And then that's the same over here for this part. 210 plus a multiple of a rotation, multiple of 360 degrees divided by 3. Okay, so this would be 5. Inside here, I could simplify a little bit. That would be 70 degrees plus 120 n. Okay, and over here, 120 degrees. And over here, I'd have the same thing, 70 degrees plus 120 n. There's a lot of neat connections when you're thinking about roots, and like the fact that 120 was there, that's because it's splitting up that whole rotation into 3 chunks of 120 degrees each. And that 70 is actually just kind of showing you the starting point. It's going to be somewhere here, and then you're going to break it up into 3 equal places. So these are going to be the locations of the roots. 3 spots equally spaced around the circle with starting at 70. And then the 5 is actually the radius of the circle. But anyway, you don't need to know that, but it's just kind of an interesting thing to observe. All right, so what you do is if you're doing cube roots, you're going to need to look at, okay, what happens when n is 0, and then n equaling 1, and then n equal 2. So if it's cube roots, you do 3 of those starting with 0. If it were a fourth root, you would do 4 of them starting with 0, 0, 1, 2, 3, and that'll give it to you. So now it's just a matter of working that out. So we'd have cosine of 70 degrees plus 120 times 0. And you might want to do that piece. I've thought about this. I think when I do it myself, I just like going 7, just doing this part, 70 plus the 120 times 0. So that's just 70. Okay. So that means that one's going to be 5 times cosine of 70 degrees plus I sine of 70 degrees. Okay. All right. When you plug in the 1, just do the 70 plus 120 times 1. So then we get the 190 degrees. So that means it's going to be 5 cosine 190 plus I sine 190. And then for the last one, you're going to do 2 times the 120, that's 240. And 240 plus 70, that's going to give you 310 degrees. So these are all 120 apart. Okay, and so then the third one would be 5 cosine 310 plus I sine 310. So what you found is 190 would be just a little past 180. 310 would be around over here. And these would split the 360 degrees into 3 equal spots because it's a cube root. The radius is 5, and then this is the 70, this is the 190, and this is the 310 spot. Okay. Now, you got to watch out about what form they want it in. So this one said to write the roots in polar form. And so we got it in polar form already. So we didn't have any more work to do. If they wanted it in rectangular form, I would actually do the cosine of 70 and the sine of 70 and then distribute the 5. Okay. I'd go a little bit further. All right. Now let's look at this number 20. Number 20 is also cube roots. We're just doing the cube root of I, and so it's not starting out written in polar form. So because it's so much easier to do things written in polar form, you're going to do that first. So you're going to think about the I, and you're going to think about it as a complex number. So it's like you have no real part and then plus one I. So it's like the 0.01. Okay. And I like to visualize things. So I like to think about it. So that's like what I got. Here's my real, here's my imaginary, the 0.01. All right, I want that written first. So first I'm going to convert 0 plus 1i into polar. So convert that to polar form so that we can apply the result we learned earlier. So you can basically do that without any calculation because you can see that's pi over 2. So the theta equals pi over 2. And then you can see that this length right here, which represents the r, or the modulus for the complex number, that has to be 1. Okay. So if I wrote that number in polar form, it would be 1 cosine pi over 2 plus I sine pi over 2. All right, so that means if I'm trying to do all of the cube roots of I, what I could do is take the cube root of the modulus, and then in here, I'm going to wind up dividing the argument by 3, but after I've written that out. And here I chose to do radian form just so you'd get some experience with that, but you could have just put 90 degrees because ultimately you're putting it in rectangular form. So it didn't really matter whether you thought of it in radians or degrees. So you could have put a 90 there if you'd rather. And if it were in degrees, what you would add to this would be a rotation that's a multiple of 360. I'm going to do 2n pi, which is the same thing, but in radians. Okay. And so I do that to both. Okay, hold on a second. I got to put the divided by in there. And I'm going to divide that inside there by 3. Divide that by 3. Okay. So I know that, let me go back to black because I think you can see that better. So I know that that's going to be 1. I'm going to move it over also. So I know it's going to be 1. And then I'm going to have cosine. And I'm going to simplify this a little bit. So the 3 is going to go into both of these. So I'll have pi over 6 plus 2n pi over 3 plus I sine, same thing. Okay. All right, so then, since it's cube roots, we're going to look at what happens when we have n equaling 0, what happens when we have n equaling 1, and so on. So I'm going to do these one at a time because this problem said to write it in rectangular form. So I may need more room, may need to go to another page. So let me see if I can get that to go to another page. Okay. Now I'm just kind of working it out. So I'm going to have 1 cosine pi over 6, put in a 0, that's gone. So this inside here just becomes that. Okay. And pi over 6, I can find that's just 30 degrees. That's on the unit circle. So I know cosine is square root of 3 over 2, and sine is a half. So if I needed it in rectangular form, all I really have to do is figure these out, and then distribute, in this case, a 1 throughout. So one of the roots would be square root of 3 over 2 plus 1/2 I. I'm not sure which way they'll write that. I'll write it like that. Okay, so there's one of them. All right, now let n equal 1 and you'll get the next one. So that means you're going to do pi over 6 plus 2 pi over 3. Okay. Okay, so you might want to just do that as a little side problem so you don't even have to write all of that. So you might just over here do pi over 6 plus 2 pi over 3. That's pi over 6 plus 4 pi over 6. I have to multiply by 2. Okay, and that would give me 5 pi over 6. So it's cosine 5 pi over 6 plus I sine 5 pi over 6. And then this happens to be a 1 in this case. If it had been some other number, that number would have to get distributed. So there's the polar form of the second root. And if I want the rectangular form, I have to do the cosine of 5 pi over 6. So I think about where that is. Okay, and so, on your unit circle, it's going to be right over there. And the cosine is going to be negative square root of 3 over 2, and the sine is still going to be a positive 1/2. So you have negative square root of 3 over 2 plus 1/2 I. So that's the second one. And then to find the third root, we let n equal 2. So let's use this idea. So we're going to take pi over 6 plus, and let me go back up where you can see where I'm plugging it in. I'm plugging it in right there. So we have 2n pi over 3, and n is 2. 2n pi over 3. So we're going to be adding 4 pi over 3. We still need to multiply by 2. That'd be 1 pi over 6 plus 8 pi over 6 is 9 pi over 6. And that does simplify. We can divide by 3, and that winds up being 3 pi over 2. So the third one turns out to be 1 cosine 3 pi over 2 plus I sine of 3 pi over 2. And 3 pi over 2, that's right there. So for that one, you can see that cosine would be 0 and that sine would be negative 1. Okay, so you have that. So that's 0 plus negative I. So basically just negative I for the third one. So there are your 3 roots. You'd have to type them in that a plus bi form. So one of them was negative I. One of them was negative square root of 3 over 2 plus 1/2 I. And then the other one was positive square root of 3 over 2 plus 1/2 I. All right, now one of the things that you might need to do is write it as a decimal. So if they wanted it as a decimal, I could have done that, and this would have been 0.9. If on that problem, when you read it, it says round to the nearest tenth, that would be 0.9. Of course, this is 0.5 I. And so if they wanted it as a decimal, this would be negative 0.9 plus 0.5 I. Right? And then, of course, that one's just going to be negative 1 I. Right? And so when they say you can write it as a decimal, that means that you don't necessarily have to go to the unit circle. I just did because I was able to, because these were angles that had a spot on the unit circle. But if they hadn't, or if I wanted to, I could just type in cosine of 5 pi over 6. But remember to pay attention to whether you're putting radians or degrees in there. Okay. All right. So I'm going to stop that.